Welcome. On this page, we're going to just take a look at some histograms that have already been created and then answer some questions about them. But we're first going to have to make a note here about a convention we're going to take. So let me read the first problem. So it says, Home Realty claims that it can sell a detached residential house faster than any other realty company. With the aim of examining Home's claim, we sample customers who sold a detached residential house through Home and record the selling time and days of these houses. And the results are summarized in the histogram. So you'll see on the x-axis, the selling time in days of houses, and then our y-axis is the counting, the frequency of how many homes are in each of these groupings, these classes. So they did not use the boundaries on the x-axis as we've learned to do. So you'll see these numbers aren't ending in our 0.5. So the problem with that is there's a little bit of ambiguity going on as to how to read the histogram. So it's a little bit unclear. So for example, if I had a house that sold in 20 days, I have no way of knowing if that house was one of these 5 houses, or if it sold in 20 days, was it one of these 7 houses? So it's unclear here to which grouping 20 belongs. So this is something we could have avoided by using the boundaries as we've learned to do. All right, but expressing it in whole numbers like this does make it a little more readable and accessible generally to a reader. So let's talk about our convention. So what we're going to do is assume that as it's presented, this first grouping, this one house, is going to be a house that's sold somewhere from 0 days up to, but not including 10 days. The next group of 5 houses sold in 10 days up to, but not including 20. So in other words, if a house sold in 20 days, we're assuming it's part of this group of 7 houses. So that's how we will read our histograms. All right, and then we're ready to answer a question. So it says, find the proportion of selling times in the sample that are less than 30 days. So on our y-axis, we have frequencies, but they want to know proportion. So let me just make a note down here that proportions can also be referred to as relative frequency versus frequency. So relative frequency. And relative frequency is the frequency divided by the number of data values in the data set. So if I want to find relative frequencies, I'm going to need to know the number of data values, and we can find that by adding all of our frequencies. So there's our capital sigma for find the sum of the frequencies. So we're just going to take all these houses in each of these groupings. So 1 plus 5 plus 7 plus 4 plus 3. And we can add those, and that will be 20 houses in total. So for our houses that sold in less than 30 days, so there's 30. So less than 30 would be those houses. So we know the frequency, 1, 5, and 7. But let's go ahead and find relative frequencies. So I'll just abbreviate RF. So in this first group, it was 1 house out of 20, plus the next group would be 5 houses out of the 20, and then the next grouping, 7 houses out of 20. And I'm going to write each of them separately as a relative frequency, just so we see it here. So 1 house out of 20 would be equivalent to 0.05. So I'm just going to write that on the graph in decimal over here. So 1 is equivalent to 0.05 or 5%. 5 out of 20, so 5 divided by 20 is equivalent to 0.25, 25%. And then 7 out of 20 is equivalent to 0.35 or 35%. So now I can add those together. So 0.05 plus 0.25 plus 0.35. And that will give us the proportion that's sold in less than 30 days. All right, so that's 0.65. And I'm going to write it as percent as well. 65% of homes sold in less than 30 days. Okay. So it'll be important to pay attention to your y-axis and what information is given. So frequency will be a whole number because we're counting houses. So let's compare this with our next problem. So for number 2, a newspaper just released the results of a study of students who completed preparation programs for a nationwide standardized test, and the histogram summarizes the mathematics test score information for the students. All right, so we have their math scores on the x-axis, and now they've labeled the y-axis with relative frequency. So they've given us the proportions for each of these groupings. And I know that not only because they labeled it there, but I see these decimal values now. So I know we're talking about proportions versus whole numbers. So they ask us to find the proportion of students in the study who scored at least 700. So at least 700 means 700 at the minimum or 700 or higher. So that would be those students from 700 to 750, 0.26, and then those students 0.08. So since they've already given us the relative frequencies, this one's a little easier. We don't have to actually find the relative frequencies. So that proportion, the relative frequency, we just take our 0.26 and add our 0.08. So that answer is 0.34, or 34% of students scored at least 700. All right, so it will always be specified if we want decimal or percent. I just like writing both here. So pay attention. If it's frequency up top and you're looking for proportion, you're going to have to find those proportions. But if it's already given as a proportion, all we need to do is add the relevant proportions together. All right, one more. So number 3 here, a recent study of a sample of US chess player details such things as the number of years the players have been active and the chess ratings of the players. So a chess rating is a number with a higher number indicating greater expertise. And this is a chess rating data set for a sample of players that's summarized. Find the proportion of chess ratings in the sample that are 1,500 or higher. All right, so 1,500 or higher would be those. Now these are counts again, frequencies. So those 15 students, those 6 students, and those 4 students. I'm saying students, but they're chess players. They could be students, but chess players. All right, so this is where first we have to find N. We need to know how many total players are represented. So we just add the frequencies together in total. So starting at the beginning, 5 plus 6 plus 14 plus 15 plus 6 plus 4. And I'll just double check here. I think that that is 50. Indeed, 50 players are summarized in the histogram, and we want the relative frequencies. So that first group would be 15 players out of 50. The next group, 6 players out of 50. And the next group, 4 players out of 50. I'll go ahead and write them each separately as a relative frequency. just so we can talk about it here. So 0.3, that would be 15 is equivalent to 0.3, 30% of players, plus, so 6 divided by 50 is 0.12, 12% of players there. And then 4 divided by 50 is 0.08, or 8% of players there. And then we just add those relative frequencies together. All right, and that comes out to be 50%, 0.5. So 0.5 or 50% of players scored 15 or have chess ratings 1500 or higher. All right, so for any histogram that you get that you're asked about proportion, so pay attention to your y-axis, and that will instruct you on how to move forward.